welcome back. It's Gracie
and Malia with another lab report.
Today we have lab number 6, Alien Ice Lab. Basically, today NASA gave us a sample from planet ATX 78757, and we had to determine whether or not the gas sample was methane or carbon dioxide.
And now, on to what we did. So, you start with a 25 milliliter Erlenmeyer flask, and then you're going to fill it with water until the stopper. Then, to determine the contents, or what the mass of the volume of the flask would be, you pour it out into the 100 milliliter beakers, and then you see what the average is. Now, then you're going to take a sample of ice and determine the mass of it based off the equation Pivnert. And then you multiply the mass that was determined 3 times so we have an excess amount to work with. Then grab the sample with protective gloves so you don't burn yourself, and then you grind up the sample of ice, and then you put it in the sealed Erlenmeyer flask. Next, you're going to weigh out the sample in the flask and calculate the density of the air in the flask. Okay, let's just cut that and we'll go.
On to the second half of what we did. We calculated the mass of the flask by using the balance to weigh it out, and then we subtracted the mass by the mass of the air, which we got from using the density equation right there. And we subtracted the mass of the flask with gas air by the mass of the flask with no air to get the mass of only the gas vapor that we got from the ice sample that was sublimed. And we let the flask sublime for it took about a minute, and we put it back onto the scale to attain the mass of all the air within the flask. After sublimation was done, we put the flask into a room temperature water bath with a thermometer, and we set a timer for 5 minutes till the temperature of the gas in the flask was the same as the water, and took the temperature of the water bath. We wiped off the flask to make sure there was no moisture that would deviate our data. Oops. And then we converted the pressure in inches of mercury the day of, which you can get from the Weather Channel, which is what we did. And then we used this to calculate for the unknown ice moles. And then we used the equation N equals RT over PV. And then we had to multiply by 3 because we used 3 times of the grams that we needed. Mm-hmm. And then we did all of that for one trial, and then we did it again for the next trial.
Wow.
Now we're going to talk about the math. So first of all, this was all of our math from trial 1. Here we have converting milliliters to liters, which is the unit that we had to use for all of our equations, like Pivnert and the density equation. In step 9, you can see that we used the density equation 0.3535 times pressure over temperature to get the density of the air that we were looking for from the ice. And then we also used the constant of 0.997 ATM, which we got from the Weather Channel for the pressure of the day. And in step 10, we used D is equal to M over V to find the density, or I'm sorry, the mass of the ice that we were using and the mass of the flask. We also had to convert, in step 14, more pressure from millimeters of mercury into ATM, which we did that in step 14. And then in step 16, we used Pivnert, and we rearranged the equation to solve for moles of the ice to figure out what type of ice we were actually using. And yeah, I think that's it. Can we use the same for... I think that's all I need to talk about. Oh, you know what? We can cut this and be like, okay. In step 10, one of the crucial parts of the whole entire experiment is subtracting the mass of the flask with all of its air by the mass of the flask with just the air from the ice, so that you can get exactly how much air from just the ice that you have, not mixed together with the air that was already in the flask, which you can see that on step 10. And we repeated all of this for trial number 2.
Like, my reading skills are so...
Shut up. Okay. 1, 2.
And now
for the
data
data
recorded.
Alright, so for trial 1, we have the mass of the gas, which is 1.32 grams. The temperature is 292.9 Kelvin. The mass of the flask with all the gas is 130.452 grams. The mass of the flask with ice gas is 130.4216 grams. The mass of the vapor is 0.1994 grams. The density of the air is 1.2 times 10 to the 3rd grams per centimeters cubed. And the mass of the ice needed of carbon dioxide is 1.32 grams.
And now for trial 2.
The mass of the ice is 1.32 grams. The temperature is 292.9 Kelvin. The mass of the flask with all gas is 1.2.181 grams. And then same for the mass of the flask with ice gas is 142.181 grams. And then the mass of the vapor is 0.1994 grams. And the density of the air is 1.2 times 10 to the 3rd grams per centimeters cubed. And the mass of the ice needed of carbon dioxide is 1.32 grams.
And now for our discussion. So we did run into a few problems during our experiment that we would have to correct next time. The first issue is the ice sample that we had that we ended up concluding was CO2. When we held it in the grinder, the heat from our hands as we were moving it from the fume hood to the scale ended up heating it up too much, and it would sublime before we could even get to the scale. And also during the grinder portion, we did grind it up to too much of a fine powder in the first time of our first trial, so we had to get a new sample and redo that portion.
And on to like data loss and how we couldn't keep all the gas within the flask because then it would break. And so there's holes on the stopper, and so we lost some of our data because of the gas like being leaked out of the flask. And then also we couldn't get it on in time. At one point the flask was too hot at the bottom and it sublimed before we could even get it to the scale. So that's the thing to kind of look for and correct, because we also lost gas while we're putting it into the water flask by walking across the room. So we lost a lot of data on the way. But I think we corrected a lot for that with, keep adding more ice than what we needed for the experiment. Finally, our conclusion.
So our molar mass that we ended up getting at the very end of our experiment was 51.16 grams per mole, and this would be similar to carbon dioxide's 44.01 grams. The reason it was over a little bit is because we did use 3 times the amount of ice that we actually needed. 51 is closer to 44 than it is to 16, which is the molar mass of methane. So we did conclude and decide that the sample ice we got was derived from carbon dioxide.
And then onto why we chose our data. So we did 2 trials, and the first trial is more usable data than trial 2, because trial 2, the mass of the flask was air, and then the mass of the flask with air and gas, and like both of them mixed together, was too similar, and it wouldn't be able to be used because you can't really discern between like 2 similar of the values. And then furthermore, this could be used in the future when NASA is looking for new planets and in their future endeavors.
Thank you guys so much for watching, and tune in next week for our lab final.
Like and subscribe for more chem content.
Me when